Welcome to this section on designing image filters. We'll learn how digital filters can be created and applied to images using MATLAB tools. Through simple examples, you'll see how MATLAB functions like imfilter and fspecial help us perform filtering operations and visualize their effects in image processing. Earlier, we used a simple digital filter filled with ones to perform a moving average, which smooths an image by averaging the intensity values within its covered region. This concept leads us to an important topic: filter design. On the screen, you can see 3 examples of 5x5 filters, each with a distinct pattern. The plots in the middle show their 2-dimensional shapes, and the 3-dimensional surfaces above illustrate their structures. When a filter is convolved with an image, regions where the image pattern aligns with the filter pattern produce larger summed values, resulting in a stronger response. Next, let's see how we can apply these filters to real images using MATLAB functions. Now that we've seen examples of typical filters, let's apply one to an image. MATLAB's image processing toolbox provides a function called imfilter, which performs the convolution between a filter and an image. As shown on the screen, the first input is the original image, and the second is the filter you want to apply. The function outputs a new image that reflects the filtering result. Next, we'll see how this looks when applied to an actual image example. Let's start applying a filter in MATLAB. First, we read a color image into the workspace. Here, we use the sample image called peppers.png, which is included with MATLAB. We use the imread command to import the image and the imshow command to display it in Figure Window 1. This gives us the original image we'll use as input for our filtering process in the next step. Now, let's define a filter using MATLAB's fspecial function. In this example, we create a variable named h to store a built-in filter that simulates camera motion. The first input parameter, motion, specifies the type of filter to create. The second parameter defines the length of the motion in pixels, and the third parameter sets the angle of motion in degrees, measured counterclockwise. This command generates a motion filter with a length of 50 pixels at a 45-degree angle, which can be used to approximate linear camera movement that might occur during image capture. Next, we'll apply this filter to the image to observe its effect. Now that we've defined our motion filter, let's convolve it with the image to observe the result. We use MATLAB's imfilter function for this operation. The first input, original RGB, is the image we imported earlier, and the second input, H, is the motion filter we created using fspecial. This convolution produces a new image stored in filtered RGB. On the left, we can compare the original image at the bottom with the filtered image above it. The filtered result clearly shows motion blur at a 45-degree angle, just as specified by the third parameter of the fspecial function. You can experiment by adjusting the filter length or angle to see how these parameters change the motion effect on the image. MATLAB provides a collection of predefined 2-dimensional filters that can be generated using the fspecial function. As shown here, you can create filters such as average, disk, Gaussian, Laplacian, and logarithmic filters, each designed for different image processing tasks. You can also define motion, predefined, and Sobel filters, which are commonly used for detecting edges and enhancing image features. Experimenting with these filter types helps you understand how each one affects an image. For detailed options and parameters, you can refer to MATLAB's documentation or help files. This concludes our discussion on filter design and how to use MATLAB functions like fspecial and imfilter to create and apply filters. Take a moment to review the concepts we've covered, and feel free to experiment with different filter types to see their effects on images. If you have any questions, this is a good time to ask before we move on to the next topic.